Okay, so today is going to be review. Now you can see in the last two quizzes, you need to know a lot of stuff, okay? But if you practice those two quizzes, you will learn this stuff. But it does take, like learning that unit circle, you do have to put the time in or you're going to have a hard time on the exam. Now, today we're going to be talking about the graph of sine x and cos x and tan x, okay? The actual visual graph of it. Now, a sine, cos, tan graph are what we call periodic functions. Why? Because they keep repeating over a certain interval, okay? So they repeat regularly. And the length of one repeat, or one interval, is called a period. Now the amplitude is the periodic function that's defined as half the distance between the maximum and the minimum values. Or what it is, from the center of the graph, how much, or how high it goes, or how low it goes. Okay? So let's just kind of get looking at these so you can understand. Now, for period, what you want to do is find where it starts, or you could go peak to peak, it doesn't matter. But this would be your period. Do you see that is, it's doing this, and then it's going to start it all over again. Okay? So we're looking for how long is one period. How long is it to do one of the shape before it does it again and again? So in this case, the period would be 8 units. Now the amplitude is the distance from the center up or the center down. Now if they're different distances, then A, you picked your center wrong, or B, it's not a period, okay? Now, the amplitude can also be done mathematically by taking the max minus the min and divide by 2. So in this case, the max is 10. The min is going to minus negative 10. We're going to divide by 2. So 10 minus negative 10 is 20. 20 divided by 2 is 10. So the amplitude is actually 10, and that should make sense even from the picture. Okay, B, what I always try to do first is find the midline, because the midline is actually going to turn out later to be my D on my graph. So what would you say is the exact middle of this graph? Okay, do a visual. What would you say is exactly middle? Center. It'll be y equals 2. Okay? Now, why does that help me? Because it does help me establish my amplitude and helps me establish my period as well. Now, by looking at this, a good way to do your period, I find, is like from peak to peak. So that would be 9 minus 3, right? So our period would be 6 units, right? What would be my amplitude? Now you can just look at it visually, and what do you think your amplitude is? How many units? From the midline up, how many is it? 4 units. Or you could just do 6 minus negative 2 over 2, which is 8 over 2, which equals 4. Okay. Now once you get your graphing calculator out, and we're going to graph sine x. Okay? So I want y equals sine x in your graph. Yes, it does. Okay, well, we'll talk about that. Now, first of all, it says in degrees. See in the question? Graph y equals sine x in degrees. So that's why we want degrees. Now, when you graph this and you're in the wrong mode, you're either going to see that or you're going to see a lot of almost looks like an erratic heart rate, okay? Now, why, like I'm in the right mode, but why am I not getting a good graph? Well, if you look at my window settings, I have done those all in radians. So we want, on our picture, do you see that the x min is negative 360? Okay, we're looking at the graph in B. The maximum is 540. Now, what is each little tick on the graph? Look on your graph. What do you think each tick is? That's called your scale. 30 degrees. Good. Okay? And it goes down to negative 1.2, up to 1.2, and the scale there is by 0.2. It's going by 0.2s. Then if you hit the graph, you get a sine graph. Okay, so I want you to look at these points here. At 0, because you can see that it is 0, right? So let's look at some of the key points. Now the sine graph at 90 degrees, this is 90, is, what's y value? 1, right? Then we come back down to 180 degrees. Now on your, do you know what I'm doing on your unit circle? I've been going 0, 90, now I'm going at 180. What's 180? Sine 180 on your 0. And do you see that we're at 0 where my arrow is? That's 180. Then I come down. Now I'm at 270. 270 is 0, 1 on your graph, right? On your, we're now there at the very bottom, so that's 1. And you see that, you know, we're 1 here. Then we're coming back up to 360, and we're at 0. So here is one period, and all of these are on your unit circle, every single one of them. So let's see how good your memory is. What would 30 be? We went by 30 degrees. What do you think 30 would be? Think about it. Come on your unit circle. What's next? Do you know your signs? 1/2. What's 60? Root 3 over 2. Okay, then we're at 1. Then what comes next? I'm going around. Root 3 over 2. Then 1/2. Then we're at 0. Then we're at, keep going around with me, negative 1/2. Then negative root 3 over 2. Then 1. Then negative root 3 over 2. Negative 1/2 and 0. Yep. Negative 1, you're right. Now if you do these in your calculator, this is what you're going to get. This is 0.5. This is 0.87. So I want you to actually know what these decimals mean so you can actually get your whole unit circle from the graph. As long as you know what root 3 over 2 is. That's 0.87 on your graph, okay? So this has everything you need to be able to find out all of your unit circle. Now, what I want you to see also, you could just watch this, is what does a cos graph look like? So if I go cos x, I'm going to come all the way over here and I'm going to make it dark and hit graph. Now, do you see where a coast graph starts at 1? Because 1, 0 is the first point. Do you see that? So here's all of your coast graph and sine graph to go all the way around. Okay? Now, the other thing you need to know is look how this coast graph, if you did a vertical translation 90 degrees right, you'd get the same graph, right? You'd get a sine graph. Or horizontal, did I say vertical? Horizontal translation. Okay? So, the domain of this graph, if that graph was actually going on forever, domain would be x in the reals, right? The amplitude is 1, x-intercepts happen at 0, 180, 360. So all we say is 180 n is in the integers. What's the range? It goes from 1 to negative 1, 1 to negative 1, 1 to negative 1, okay? So it's negative 1, x, 1, y is in the reals. Period. How often does this thing repeat? Every 360 degrees. See on the unit circle? And 360, and then back to 30, 60, 90, okay? And back to 360, then 30, 60, 90, okay? The y-intercept is at 0. So 180. Okay? So a coast graph is what I just kind of showed you. So we're not going to go through that. So you're doing 1 to 12 on this one. Okay, let's go on to the next. Okay, doing a double lesson today is money in the bank because all those people going the Jasper trip. Now, period 4 actually realized that was during the exam, or the Jasper trip and exam were on the same day. So the Jasper people said, we want to write it before the trip, not after the trip. Okay, so I've moved everything ahead one day, which actually gives you one more day of studying at the end of the year. And I was worried about at the end of the year because I have 3 practice diplomas for you to write and basically 3 periods. So now you'll have 6 periods to write. So one diploma exam you can write in 2 days. You can really go through it well. You can, instead of, okay guys, next day here's another diploma, next day another diploma. So it'll give me 6 days to work through the practice diploma and 1 day to do your replacement test and 1 day to go over your replacement test. So now we have 8 days at the end of the year to work on all of this stuff. Okay? We only had 7 before, so that's good. Now, this one should be total review. Okay? One more time we're doing transformations. Now, you have to know these forms very well. Okay? And I want you to look at this. Who does the A belong to? So this is, yeah, but what is this? Vertical stretch. What's this? Horizontal stretch. This, horizontal translation. This, vertical translation. Okay? These A, B, C's, and D's also stand for altitude. Now, why is altitude the same thing as vertical stretch? Come on, think about it. The more you stretch it, the higher the altitude gets. Right? The altitude was 1. So if I do a vertical stretch by 3, it should be 3 now. Right? Okay? And then B, you'll start to see, has to do with the period, and C and D are moving it. C moves it this way, D moves the midline the middle, which of course the rest of the graph goes with it, up and down. Okay? So we're just working with two things today, the A and the B, and then we'll introduce C and D next class. Now, let's just do a couple to get warmed up. Now, what would this be? Y equals sine x is the original. So y equals 2 sine x. So I'm just going to pick somebody randomly because we have done many of these. What's the replacement, and what would be it in words? Okay, Felicia, what's the replacement? So y goes to 1/2 y, which is a about dx. So do you see how, since we stretch it by 2, oh, that makes my amplitude 2. So that 2 in the front is also still relates to vertical stretch, but it actually is our amplitude. Okay? How about this one? Let's do this. Okay, let's pick on Wiley.
X goes to 3x, and x goes to negative x.
Awesome. Okay. Nice job. Okay, so today we are studying the transformation unit again. So you got to see why I'm really happy to be doing the trig last, because you see all the stuff you have to learn? What if we did this unit first and then added 4 months on top of it? Whereas you're going to know trig, the last thing you do, and you're reviewing the very first unit all the way through. Okay? We're doing all the transformation unit again. So, yes, I know that sucks that we have to do all this hard stuff and we're doing transformations again, but let's face it, we're studying for a final exam here, so this is a good time to do it. Okay, and we're going to finish it all in May, except for one. We have 1 day of notes in June. That's it. So now we're not going to go through all of this right now, but I just want you to. What does A do to this thing? It stretches it, right? Now, what does B do? Stretches it this way. Now, if B is 2, what would it do to this graph? If B is 2, it would make it like this, would it not? Because it's a horizontal stretch by 1/2. If B is 1/2, and this was my original, it would do a horizontal stretch by 2. So it stretches that thing out, right? If you can picture just this wire, and you're in and you're out, okay? That's horizontal stretch and vertical stretch, okay? But remember, we're doing it by both ways, right? Not just top, both ways it stretches, okay? So, let's go to the next page. Okay, so if A is greater than 0, right here, that's just a vertical stretch by a factor of A. Now, we're talking about A's on that side, right? So that's why it's a vertical stretch by A, but it really belongs to the other side, which would be 1 over A, which is a vertical stretch by A. Now, if it's less than 0, it has two things, okay? And Wiley just did one with the B, but it has to be a reflection and a vertical stretch. A being less than 0 means it's negative, so there's two things going on there. Now, we're going to learn more about B, but B, as we know, is your horizontal stretch. Now, if you have this, A equals A sine BX, or Y equals A cos BX, how do you find A? That's the amplitude. You can go max minus min over 2. We did that already. Okay? How do you find the period? The period is just take 360 divided by B. If it's in radians, 2 pi divided by b. And remember, some people were still doing this in the quiz. If the question's in radians, the answer must be in radians. If it asks for exact answer, must be in radians. Okay, I don't want decimals. Now, this is very important. Get this on a study sheet, that if it's a tan graph, you do 180 divided by b for the period, and b pi divided by b. Now, why is there no amplitude? Well, I think it's probably better to look at what a tan graph looks like. So I'm going to get rid of this. You guys can just watch. This is what tan x looks like. And I want you to think about the unit circle. Tan starts at 0, and where does it go at 90 degrees? Undefined. It goes to infinity. So this is what a tan x graph looks like. Those are all asymptotes, those straight lines. So it goes from 0 to infinity and 0 to negative infinity. That's why it doesn't have an amplitude. There's no such thing as an amplitude for something that goes on and on for a height forever. I guess the only thing your amplitude would be is undefined, right? So we just say it doesn't have an amplitude. But period, it does it every pi, not every 2 pi. Because you can see on your graph that it goes 0 to undefined, all the way to 0 to undefined, 0 to undefined, 0 to undefined. So it does not ever go to -1 or +1. It just goes to undefined, okay? So know these two charts really, really well. Okay, now we're actually going to draw a 4 cos 2x. Okay, now let's draw first of all a cos x, because we're going to go off that. So cos x starts at 1. Okay, then it goes down to -1, then it comes up through pi, and then up here, and down at 2 pi. Okay, that's what a cos graph looks like. Now, what are we doing here? State the amplitude. What's the amplitude? Amplitude is 4. What's the period? Now, b equals 2 pi over p. So in this case, I'm asking for p. What would p equal? Two pi over b. Right? So the period is 2 pi divided by b, which is 2. So the period is pi. That's what the new, so I knew my new amplitude is going to be 4. My period is going to be pi. Now, what I want to do is, I want to do my old way of thinking and graph this thing. Now, this should be rewritten as 1/4 cos, or 1/4 y equals cos, sorry, equals cos 2x. Now, to me, that is a y getting replaced with 1/4 y and an x getting replaced with a 2x. So that is a vertical stretch by 4 and a horizontal stretch by 1/2. Okay, what's wrong? Yeah, ask. Because period is 2 pi over b, right? my new graph is supposed to be pi. This is y equals cos x. What I'm doing is taking y equals cos x, and I'm going to do y equals 4 cos 2x. Okay. So now, first thing I want to do is I want to, I'm going to do with my stretch, I'm going to do a horizontal stretch by a half. So I'm going to half every single point. Now, this point right here, can't really half it, okay? I can half this point, okay? So it's going to be like over here. I can half this point, it's 3, it's going to be there. I can half pi. Pi is going to be 90 degrees. So all I'm doing is take all of these and I'm bringing them in, right? I'm bringing them in. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9 away. So it's going to be 1, 2, 3, 4.5 away. Okay, so all I'm doing is I am, actually erase this because it looks like a point. I'm taking this point, multiplying it by a half, brings it in. This point, multiply it by a half, brings it in. This point, multiply by a half, bring it in. This point, multiply it by a half, and I'll bring it in. So after I've done a horizontal stretch by a half, so this is the graph y equals cos 2x. Everybody see what I'm doing here? Now, what would y equals 4 cos 2x? Well, I'm going to take every y and multiply by 4. Okay, so this one comes up here. This one comes down here. Okay, this one's staying where it is. This one's coming up here. And that one's staying where it is. So this is what my okay, and if I take this and actually clone it, and okay, that should have worked out nicer. What are you doing to me here? Okay, so that cloned horrible. That's what happened. Okay, it obviously went down too much. So now we get to see actually twice as many graphs in that. Okay, so what do? You do your times by half and multiply by 4, and then you get the new function. Yep. Oh, I should have just drawn it freehand, but because I have a cloning tool, I thought it'd show off, and it didn't work very well. But because basically, it wanted over this domain, so I had to keep going to get it over that domain. If they would have went just over pi, then right, has to go to 2 pi. Okay, write this equation. Having an amplitude of 2/3 and a period of pi over 6. Now remember what I'm looking for. Y equals a sine b of x. So what is my numbers that I can put into this thing? What can I get in there? y equals what? 2 over 3 sine. Now, b, I have to go find it. That's 2 pi over divided by pi over 6. That's what that means, right? And that's the same thing as 2 pi times 6 over pi. Pi's cancel, and you get the answer 12. So b is 12. So 2/3 sine 12x. So I want you to think of the sine graph. What would I be doing with it? Will I be squishing it or pulling it out? Squishing it, right? By multiplying every point by 1/12. What would I be doing with the amplitude? Pulling it or squishing it? Squishing it, okay? Because that's a horizontal or vertical stretch by 2/3, remember? Because it's on that side. So they have opposite rules when they're on the same side. Remember how I said I didn't want to teach it to you that way? Well, you can still bring it over, and then you go, oh, it is the reciprocal, okay? So remember that A is the vertical stretch. B is the reciprocal of the vertical stretch, the horizontal stretch, okay? Now, we've got a cosine function, amplitude 3, and a period of 720, okay? So amplitude is 3, right? B equals 2 pi, or sorry, in this case, I'll go 360 over 720, and that gives me 1/2. So it's as simple as writing y equals 3 cos 1/2 x. Okay, let's just look at a picture and see if we can come up with the equation. Now, is this a cos graph or a sine graph? Sine graph, because it starts here. It could be a cos graph with a vertical or a horizontal translation on it too. But we haven't learned horizontal translation, so we won't worry about it. So what's the amplitude of this one? Just look at the graph. What's the amplitude? 3 units. What is the period? No, it's not 2 pi. See, the way you can do it, if you like, is these two would be like a, or, because it goes like this, right? Right, that's 1, and you got a negative pi over 2 and a pi over 2, so period would be pi. So now, determine the equation of the sine function. Oh, they were nice enough to tell us it was a sine function. So A is 3, I got that. B is 2 pi over pi. So it is y equals 3 sine 2x. It's pretty simple stuff once you see it. But again, a few more rules to write down in the old study sheet. Okay. Now, let's figure out the equation of the tides. Okay, now tides are very periodic. Tide goes in, tide goes out, tide goes in, tide goes out, and it's usually done on a very regular time intervals. If you've ever been to any port or whatever, you'll see a lot of ships just sitting out in the water. And they're just all congested there, and they're just, they're sitting far away and they're out there. What they're waiting for is for the tide to come up, then they come in, then they get all their stuff off, then they get back out before the tide goes back down again. Okay? So you could see how if you don't know when the tides come in and out very good, bad things can happen, because if your ship is in and the water goes down, they actually crush. It's too much weight for them, like for the water, right? So, and it damages the ship, and of course they would tip, and then they get beached and stuff like that, so it's even more work. So if you're lucky and it gets beached and you haven't destroyed it, you have to wait for the tide to come in so it comes back up and out, right? But it's pretty hard on a ship to actually be, beached or grounded. So knowing the tides, so there's a person that is just, well, I'm sure it's not one person, but there'll be a harbor master that will let everybody know, and pretty well everyone on a ship would know the tides for that port as well. So what would be the equation to find out at any time what the height of the tide is, okay? So height T, this is what height T stands for, A cos B T. Now, which one of those letters am I most concerned about if I'm a ship? A, amplitude. I want amplitude to be high enough that my ship can come in and not hit the shore. Okay? So, now time is what time I would be coming in to get that height. Now let's look at this graph and we can figure out the exact formula for it. So, what's amplitude? 4. What's the period? 12 hours, right? So all you have to do is figure out B. Now, B is 2 pi over 12, right? Which equals pi over 6. So your height at time equals 4 cos pi over 6 t. One to 6 ACE and 7 to 16. Question. The 2 pi, it's always going to be either 360 or 2 pi over b.
You know it's 360 by just the graph?
It'll always be 360. Or the reason why I did this one in radians was I don't know, I guess I could have done them over both. Nancy, do you actually listen to the Who?
Yeah, I do.
Oh,
And I'm going to Trooper tomorrow. So excited.
I have seen Trooper.
Really?
Here for a good time, not a long time. The sun don't shine every day. Yeah,
They're coming to
that's like my motto for life.
They're coming to the arena.
Yeah, they usually do small venues.
Yeah, but I think it's a beer gardens too, because it's the 18.
Are you 18 now?
Yes, I am.
Oh, behave yourself. Where are you escaping to?
I had to work on. I have to finish up my stained glass food option.
You're what up?
But I did a stained glass food option. I
Okay.
need to pick that up.